Alright, next what we're going to do is we're going to look at how to solve these problems using what's called the quadratic formula. So let's start with an example that shows us why this is necessary in the first place. So let's say we have this quadratic, x squared plus 2x minus 8 equals 0. In order to solve that, we would do what we did in the previous examples. Let's try and get x by itself. So we take this and we're going to add 8 to both sides, and now we get x squared plus 2x equals 8. And remember, we're trying to get the x by itself, and now what? There's no way to do that. There's no way to get just x's on one side because we have that x squared and the x term both over there. So we cannot use that technique that we learned last time. It's completely useless in this situation. So we need something else. And that something else is called the quadratic formula. So when that technique that we used before, solving by taking a square root, when that doesn't work, we're going to use the quadratic formula, which is this. If we've got an equation in the form ax squared plus bx plus c equals 0, we use that formula that you see there. And the common student reaction to their first exposure to this is a face that sort of looks like this, because that thing looks big and intimidating and ugly. But I hope by the time we're done doing tons and tons of example problems with this and practicing it yourself, that this thing actually becomes kind of friendly over time. It's really not that bad. But before we move on, let's look at this up here, because this is surprisingly important and easy to just blow past. A, B, and C represent numbers, and it's just the coefficient, so that x squared is not part of A. A is just a number and nothing else. Same for B, and then C, of course, is just a number. But if we're going to use the quadratic formula, if we're going to use this beast down here, this part has to be equal to 0. And if it's not equal to 0, we need to manipulate the equation, that is, move things from one side to the other, until this does equal 0. Because without that equaling 0, this does not work. So that is a really, really important feature before we even look at anything else. Make sure that it's equal to 0. Alright, now that we've got it equal to 0, let's take a look at how we might use this thing. We said we were trying to solve the quadratic x squared plus 2x minus 8 equals 0. So we rewrite the quadratic formula down here, and I want you to write it every time you work one of these problems. That'll help drive it into your memory so that you don't forget it, and will make you faster at solving these problems. So we write everything down, and then we identify A, B, and C. So A in this problem is the coefficient of x squared, so here it's just a 1. B is the coefficient of the x term, which is a 2, and C would be negative 8. So all I do is I substitute those numbers in. So you can see the B's have been replaced with 2's, the A's with 1's, the C's with negative 8's. Don't forget about replacing this part down here. And math ensues. I'll show you how to do that in the example video. But we're going to end up with two answers. So here we get x equals negative 2 and x equals 4. Both of those are solutions. I write it this way. That just means that x could be equal to a collection of things, so x could be negative 2, or x could be 4. So that's the quadratic formula, this right here, and we just plug numbers in to solve it, and to get our solutions, making sure that it's equal to 0. Now, just like when we solve these things using a square root, we can have two solutions, or one solution, or no real solutions. And in order to figure out which is going to be the case, we can use something called the discriminant. And the discriminant is the part of the quadratic formula that's inside the square root, the b squared minus 4ac. So if you just take that part, the b squared minus 4ac, and you calculate what that is, what's going to happen is it'll tell you how many solutions you have. If the discriminant, b squared minus 4ac, comes out to be positive, you're going to have two real solutions. If it comes out to be 0, you're only going to have one solution. And if it comes out negative, you're not going to have any real solutions. Now remember, that means there are types of solutions, but not of the kind that we're going to talk about in this class. So again, the discriminant will tell you how many possible solutions you have, And the quadratic formula, once you have everything set equal to 0, is going to give you your solutions. And the nice thing about the quadratic formula is it works every time.